Hello there, welcome to the lesson 6. The lesson 6 is on factoring quadratic trinomials. Now we will look into the learning objectives. There are two objectives, that is to determine the factors of trinomials with a leading coefficient 1. Now you know trinomials, say for example like this. Now if the leading coefficient is 1, then we can solve it easily by factoring. And then if it is not 1, say for example it's 2 and over here something else, then it's a different method. So we will learn both the type of problems in this video. The keywords are prime polynomials. Now, prime polynomials are nothing but, if you can't solve them directly, if you can't write them in terms of two polynomials, then we call them prime polynomials. We'll look into them. So now imagine you have this problem over here, x squared plus 8x plus 15. Now you can write this in terms of two polynomials, so it's not a prime polynomial, but how do we solve this? Now over here, we had learned this, in the last lesson, that we can split them up into two terms and we had taken common factors. But you can see over here, there's only one single factor. How can you take common? It's not possible. But if you split this 8 into 3 and 5, now say for example, x squared plus, say I'll write over here, 3x plus 5x plus 15. The methods are different. I'm just trying to explain a few things over here so you understand better. Now, if I split this 8 into 3 and 5, then what happens is basically I can split it. I can remove x common out over here and you're remaining with x plus 3. And here I can remove 5 common out. You're remaining with x plus 3. And you can see the two factors are x plus 3 and x plus 5. So this is one way. This is what we had done in the last lesson. But how would you know this is 3x plus 5x? It's not easy. I can't just write. I even can write 2 and 6, but then I wouldn't be able to solve it. I can't write 4 and 2. 4 and 4. I need to specifically write 3 and 5. Now, how would you know it's 3 and 5? This is by a method, that is, you need to see the last, last number. What is it? 15, right? You need two numbers. Sorry, it would be better like this. You need two numbers. When you multiply them, the answer must be 15, and when you add them, it must be 8. So what are those numbers? Multiples of 15. See, 1 into 15. 2 is not possible. 3 into 5. That's it. Those are the possibilities. Try 1 and 15. When you add up, will it be 8? No, but try 3 and 5. Now you can see when I multiply them 3 and 5, it's 15, and when you add up, it's 8. So this is the two terms which you need to put it over here and split it out. So 3x and 5x. You can write it anyhow and you will get the answer. So this is what can be done to solve. But now it's, how do we do it for any problem? We will see see some more problems. But there is a shortcut method in calculator, which I'll tell you in the next slide. And about prime polynomials, basically, if you can't write any polynomial in terms of product of two. See, now here we have done the step, right? We got the two terms, 3 and 5. If we can't do this, then it's called prime. And I will tell you how you can understand, because prime polynomials can be solved in your calculator. How to differentiate is very easy. So we will see the first problem. Now look at it's not just 18, it's really multiple of, you should multiply these two terms. It's 18 times 1, so we just write 18. And now we are dealing with coefficient of 1 itself. So we do not need to multiply, directly write 18. And then you need to get the sum of -9. So this is important, the sign. It should be -9, not anything else. So what can you add to get -9 and multiple as 18? Let's start with the multiples of 18. It can be 1 and 18, 2 and 9, 3 and 6, 4, 5, 6 and 3. 6 and 3 would be the same thing. 7, 8, 9 and 2. Okay, so these are the main multiples. You can't exceed more than 18, so it must be within that. So just note down few, maybe 5 to 5, maximum 5 of the multiples, and you will get the answer. So let's start with 1 and 18. add them up. It's not negative 9. Add them, add them. None of them are negative 9. So what to do now? We need two terms, but the sum must be negative. When you look at this, you must understand, oh, it must be minus. So let's try minus. You can't keep only one side minus. Now, even if you try summing them up, it'll be not minus 9, because over here it will not be the same. So try subtracting both, adding negative sign to both. Here it will be minus 19, no. Minus 11, no. Here you can see it's minus 9 and the multiple is 18. If it was 1 minus 1 plus, it would be negative 18. It's wrong. We need positive 18. Yes, minus 3 times minus 3 times minus 6 is positive 18. And when you add them, it is minus 9. So the terms are 3 and 6. So basically, you split this middle term into minus 3 and minus 6. This is all not true. Okay, I'll just write it over here. X squared minus 3x minus 6x plus 18. This is how we split it. Now you can remove the common term out. X into x minus 3. Over here, you just take 3 out, positive 3. Okay, no, sorry, negative 3. Why? If you take negative 3, these both will match. Take minus 3 out, your remaining, no, take minus 6 out. Sorry, not 3. Minus 6 out. The greatest common factor must be removed. So then you will get x plus 3 over here. X minus 3, my bad. Now you can see these two are same. It is x minus 6, x minus 3. This is the answer. What is the value of x? X will be 6 and x will be 3. So this is how we get it. Now that's what is written over here. Yes, finally we are just writing the factors over here. So this is the step. It is x minus 3, x minus 6. Now is there a shorter way? Yes. Take out your calculators and try pressing mod. Equation is 5 and then type pressing 3. This is how you solve polynomials, especially quadratic equation. Quadratic is whenever you have power 2. So if you press mod phi, and you can see the standard form matches ax squared plus bx plus c equals 0. So press 3, and now what do you need to do? Write the coefficients. The x squared was mentioned over here. If you go to mod phi and see third, x squared is there. What is before x squared? The coefficient, something that's before, that is nothing over here. That's 1. What is the b value before x? It is minus 9. And what is c value? C value is the entire thing over here. That is 18. So press C. Now we write 1 minus 9 and lastly we have 18, and answer of x is x equals 6 and x will be equal to 3. So these are the two answers. Now we don't have the correct ones, right? No, this is correct. It's just that you will take the 6 inside the equal to. What happens whenever you bring it inside the equal to? The sign changes. It becomes x minus 6 and x minus 3. So this is the thing. This is x equal to 6, say x1 and x2. So bring it inside over here, because the sign changes. It will be minus, it's plus, it'll be minus. If it was minus, this would have been x equals 3. That is the answer. So you can check your answers in the calculator easily. Let's see another problem. So we'll stick to this easy method. Mod phi and 3, and it's over here 1, phi and minus 14. All you need to get is the x value is. So now I'll directly write the factors. I know x value is given as 2, so it'll be x minus 2 is one factor, and one more factor is x. If it's minus 7, it'll be plus 7 over here. These are the factors. Let's see the answers. And those are the factors. You can see x minus 2 and x plus 7. So easy. Even if you find the factors, you will get the same answer. So whichever is easy, just follow that. Let's do this one quickly. Now, before that, if you want to go to the normal default mode, computation mode, you should press mode and 1. You will be back over here and you can do any of this solvings. Now, to go to solve this problem to factor, it's mode phi and 3. All you need to do is type them out. 1 minus 3 and minus 4. That is x minus 4 and x plus 1 are the factors. X minus 4, x plus 1 are the factors. We can just check it. That is the answer, x plus 1 and x minus 4. Please do try to solve these by yourself. You can try the long method as well. It is the same thing. Or you can just, try the calculator method. It's one and the same. After all, you need to get the correct answer. So I hope you have tried. Mod phi 3, 1 minus 4 and plus 8. And the answer is, okay, now this is important. Now the answer is I. What is I? I is imaginary number. It's not true. Now I was found out when I forgot the scientist's name. Euler, not Euler, someone, and that's a very funny thing, because they were doing a lot of work and they started doing a theorem or something, and he was getting root negative I in his works, okay, when he was trying to solve some theorem or something. And back then, this was wrong. If you get this answer, it's basically wrong. You are not supposed to get this answer. Why? Because you can't have a negative number inside a square root. Okay, so that's why what happened is, okay, he thought his work was wrong, so he went elsewhere. Everyone were getting the same thing. And then what they termed is, okay, our work is not wrong. This is correct, and this needs to be something not real. So they told this is imaginary, I. I is imaginary number, and it is given as square root negative 1. Now, and we are getting this as the answer. So what does it mean? And we are getting x1 and x2. It's always conjugate. You saw the first one was 2 plus 2i. Next one will be 2 minus 2i. It won't be the same. Now, what does this mean? This means this cannot be factored out. Let's see, trying to get the factors 8 and minus 4. Let's see the factors of 8. It is 1 into 8 and 2 into 4. 4 into 2 and 8 into 1. So these are the factors. So they repeat, so we don't need to take these. It's fine. These are the fine things. Now over here, let us consider 1 and 8. There is no way you can get it as 4. This is not possible. Now let's consider 2 and 4. Again, it's no way you can get it 2 minus 4. That means this cannot be factored. Hence, it is prime. So this cannot be written in terms of product of two polynomials, and hence you can see this is not possible, and this trinomial cannot be factored. Trinomial cannot be factored using integers. Therefore, it is prime. If you get I in your calculator, that is a prime. Yeah, that's it. Now you can try solving these in your calculator and then check the answers. It is just mod phi. I will do the last one. It's mod phi 3. Over here, the previous term is 1. There is 3. And lastly, there is minus 40. And the answer is phi and minus 8. That means x minus phi, x plus 8. Let's see. X minus phi, x plus 8. Now, please do the others and check, verify your answers. Now we have a real world problem. Switzerland's flag has a very unique shape, and it is a square. However, the flag is used by the country's naval vessels. The flag used by the country's naval vessels is rectangular as shown. Okay, if the area of the square flag is x square minus 6x plus 9 square feet and the length is increased by 4 feet, then what is the area of the naval flag in terms of x? So, sorry. Now, over here, that's great. You need to basically factor this out. Okay, let's first factor this out. How you're doing is finding the two terms, or all you need to do is mod phi 3 and simplify this. 1 minus 6 and 9. What are you gonna get? 3. Okay, now this is one more important thing. Let's see over here. The answer is minus 3 and minus 3. Look, whenever you solve and you're just getting x, you're not getting x1 and x2. Remember, the given question was x squared plus something something. It's quadratic. The highest degree is, see over here it is, highest degree is x to the power 2. That means there must be two solutions, isn't it? But you can see in the calculator you're just getting x. That means x1 and x2 are same. If you're getting x1 as 3, x2 is also 3. So you must take it inside. It's x minus 3, x minus 3. This is an important thing to remember. Don't get confused. Okay, I'm just having a single answer. No, it's just that you need to remember that they are the same terms. Now, sorry, sorry, the length is increased by 4 feet. So the factor representing the length must be increased by 4 feet. Now, what it means is there are two terms when we factored out. See, this is given over here. So this is what a square flag would look. Let me write it out. A square, sorry, that's a rectangle again. Okay, that's also a rectangle. Now just imagine this is to be a square. Okay, now this was the equation for the area. We found out the factors are x minus 3 and x minus 3. But whenever they have, naval vessels for the army, they'll have huge ships and everything, right? So whenever they use this flag, they make it rectangular rather than square. So the length is increased by 4 feet. So this one of the factor, instead of minus 3, you need to add 4. Why? Because that's increased by 4 feet. That's it. So that is what we are doing. One of the term is being added by 4. So what is the answer? X plus 1. Minus 3 plus 4 is plus 1. X plus 1, x minus 3. Now you can multiply these inside, which we have done in multiplication of polynomials. It will become x squared and minus 3x, 1x or x and minus 3. And then minus 3x and plus x is minus 2x. And this is the answer. This is the new area for rectangular flag. So this is the answer. So first what you have to do is factor out and find the two terms. The area was given. So when you factor, you'll get two polynomials of the square, that is length. Because it's a square, it must be same. Okay, both the factors must be same. X minus 3, x minus 3. It's just that length is more, so you add 4 over here and then multiply and find the area. This is how you solve this problem. Now, factoring trinomials. Okay, it's about, factoring trinomials with a leading coefficient other than 1. So if you're solving it by the concept over here, it is a little bit lengthy, but if you're solving by calculator, it is just the same method what we followed a while ago. Now I will just tell you how to solve it without calculator first. Whenever, now this is important even for the calculator method. Whenever you see here it's other than 1, you must try to take the greatest common factor out. Obviously the variables is not common over here, so x can't be removed. But what else is divisible in all? 4. We had done this in the last lesson. So divided by 2, it's 2. This is a prime number. Stop it. 18. Now this divided by 2, it will be 9. Divided by 3, it will be 3. This is a prime number. Stop it. Now what about 10? It is again 2, it will be 5. This is a prime number. Stop it. Now 2 is common in all, so you must remove that as the factor, and you're remaining with 2x squared plus 3 times 3 is 9x minus 5. This is the factor. So why this is important? I will tell you why. Now mod phi 3 in calculator, if you solve this, 4, 18 and minus 10. What is the answers you get? Okay, here you got x equals half. I will tell you how to solve this in a while. And x equals minus 5. So let's take this to the other side. It would be x negative half, or, so you can see this is division, right? Take it to the other side or multiply both the sides by 2. Multiply both the sides by 2, you will get 2x over here. 2x equals 1. Why? Multiply 2 here, it will be 2x. Multiply 2 here, it will be 1, because 2 and 2 multiplied will be cancelled with the denominator. Now take this 1 to the other side, it will be 2x minus 1. I hope this is clear. 2x minus 1. Now here it is very simple, x plus 5. Okay, this is how we write it. This is fine. But what is the problem? If I do mod phi 3 and solve this term, I've removed the 2 common factor. Now this cannot be removed. I can't simplify this more. So 2, 9 and minus phi. Again, I'm gonna get x is equal to half, which is written over here, and x equals minus phi. Why? Because they are equivalent equations. You're just multiplied. Equivalent equations have the same solution. If you recall maybe the first or second lesson, we had seen that equivalent equations have the same solution. This is important. So you simplify the equation to the lowest form and then put it in your calculator and solve. Otherwise, you'll get an error. Now, here there is 2, right? That must be also a factor. It must be written like this. This is your final answer. See what is done? You need to factor out, take the greatest common factor out, 2. Okay, and then now you have to simplify this over here. Now if you're solving manually by that long method, what happens is, can you see this first term and the last term? You need to multiply them. Negative 5 times 2 is 10, so it will be negative 10, and when you add two numbers you must get 9. So which are the two numbers? That is what we'll have to do. See, these are all the factors. And over here, okay, one second, let me find out which 10 times 1. Okay, it's very simple when it's close to each other. Whenever, okay, this is one more thing. If you're doing this method, whenever you see this number and this number very close to each other, just difference of 1, consider the same number multiple of 10 itself. Okay, positive 10 times minus 1. Why? Because this is minus, so 1 must be negative. 10 minus 1 is 9, and 10 times negative 1 is minus 10. So these are the factors. I will have to write 2x squared plus 10x minus x minus 5. Now let's simplify this. Remove 2 common out over here. 2x outside. Okay, 2x is gone out. You're remaining with x plus 5. And over here remove minus 1 out, you're remaining with x plus 5, and the two terms are 2x minus 1 and you have x plus 5. This is what we had got, x plus 5, and over here we had got x equals half. How do we do this? Multiply both the sides by 2, you'll get 2x equals 1, and take that 1 to the other side, it'll be 2x minus 1. This is it. But now it's not all over. I hope you can remember this. You can pause and see the steps. Now it's not all over. This is the factors of the inside term. Remember, this 2 is outside, so whatever I wrote over here, I have to multiply 2, because when you multiply, it's all same, right? It's multiplied. You don't need to put brackets, but remember that 2 is still there. Now this is the final answer. So if in your options, if you get this, you might have one option which is just like this. So don't think, think twice whether it's reduced, and then check which is the greatest common factor, and that has to be multiplied as well. That is how we solve this. And let's see, over here the c value was negative, now it's positive. We can try this. First of all, see whether there is an equivalent equation, or you can simplify this. Sadly, you can't, because 17 is a prime number. Even 21 is a prime number. You can't take anything common out, so you can't. You can directly do it in calculator. Mod phi 3. The first term is 2, then it's minus 17, and last term is 21. Now, if you're thinking, why is the c positive, c negative? That is if you're doing this factors by the table method, okay? You need to find the two multiples, then this matters. If you're doing calculator, it doesn't matter. But still, the method is same. You have to just multiply this and this, and then now, for example, 21 times 2 is 42, and over here it should be negative 17. Find the two factors. Okay, it's if you're thinking about it, it's nearly 7. How many times? 7 5s are 7 6. Okay, it's not so easy, to find the factors. Let me just skip ahead. Okay. This is the factor, 3 times 14. Yeah. Why? Because 3 plus, you can find the relationship. 3 times 14 is 42, and also 17 is there. Anyways, now if you're doing the calculator method, the answer was, wait, did I write it all right? It's 2, negative 17, 21. Yes, first one was a simple answer, x plus 7. Okay, sorry, it'll be minus. This is x equals to 7. When you write it as fact, it'll be minus. What about the next one? This needs to be solved. X equals 3 by 2, that is 1.5. Multiply 2 on both the sides, it'll be 2x equals 3, and minus 3, it'll be 2x minus 3. So it's over here 2x minus 3. These are the two factors. Now we will just check the answer. The answers are, sorry, 2x minus 3 and x minus 7. That's the answer. The calculator method is very easy. It saves a lot of time, a lot of stress, and you can use that because you are allowed scientific calculators, and it just saves time. But try to know the concept, because this method is useful. Now imagine you're stranded somewhere without calculators. I'm sure this problem won't pop up there, but imagine you have been given to solve this without a calculator. Then the method is important. So please make sure you understand the method and then try to use the calculator method. That's it for this lesson. I hope you have learned something new. All the best, and I will see you in the next video. Bye bye, guys.